So numbers can be broken down into many various types. The first type of number is a natural number. So a natural number can be any whole number between 1 and infinity. So basically, positive numbers are all natural numbers. This does not include negative numbers. If you say -1, -2 is a natural number, then you are mistaking it for an integer. But we'll get into that later. Number 2 is odd numbers. So these numbers are whole numbers that cannot be divided exactly by 2. This can include 1, 3, 5, 7. So to note, take this to note, any number that does not have a 2, 4, 6, 8, or 0 will be counted as an odd number because all these can be divided by 2. So let's say you have 11, 15, 17, 19. All of these will be counted as odd numbers because they cannot be divided by 2 and they will not give a remainder. Basically, that's why they mean by cannot be divided exactly. When they mean divided exactly, they mean that when the number is divided, it will not have a remainder to remain. So after that, we go on to even numbers. Even numbers are whole numbers that can be divided exactly by 2. So in this case, it can be 2, 4, 6, 8, and 0. This can be 12, 16, 26. All of these are even numbers as they can be divided exactly by 2. So aside from that, we go on to integers. Integers are negative or positive whole numbers. This is different from natural numbers as integers will contain both positive and negative. As well as this, take this to note, 0 is not a natural number because it cannot be counted as both a positive nor a negative, so it will not be a natural number. As well as that, we go on to prime numbers. Now, prime numbers are whole numbers that's greater than 1, which has only 2 factors. Now, these factors, when you look at it, one sec. These factors, I'll give an example here, 2. 2 can only be divided by 1 and 2. So that means that prime numbers, they are whole numbers that can only be divided by 1 and itself. As you keep on moving through different numbers, you notice that there are more numbers that tend to only have, or rather, there are numbers that have only 1 and itself as a divisor. This can include both 2, 3, 5, 7, 11, and it goes on. So all these numbers can only be divided by 1 and itself. After that, we go on to square numbers. So square numbers, they are the products that can be obtained when an integer is multiplied by itself. This can include 1, which is 1 times 1, now equal 1, 2, 4, which is 2 times 2, 9, which is 3 times 3, 16, which is 4 by 4, and the list goes on. So number 7 goes to fractions. Fractions are a number representing a whole number written in the form a over b, where a and b are non-zero integers. This can include 1 over 2, 1 over 4, 1 over 3, 1 over 8, and the list goes on. And number 8 is lastly decimals. Now decimals are a number that is used to place value, that is used as a place value and a decimal point to show a fraction. You can see, for example, 5 over 2. Steve. 5 over 2. When you put this into your calculator, it will give you 2.5. 2 is the place value. And 5.5, to be exact, is the decimal place. So take this to note. So as long as that goes on, we'll go on to real numbers. So real numbers are any number that can be thought is any number rather. Real numbers rather are any number that can be thought of, except for very complex numbers. So this can be taken as, you can think of any number that can be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. You can think of a fraction like 5/2, 7/2. You can even think of a square root or square number, anything like root 4, root 16. The only thing, these numbers can be thought of and they can be any kind of different number. So the first type is rational numbers. Rational numbers can be written as fractions, and they include all integers, fractions, terminating decimals, and recurring decimals. This can be seen mostly with numbers that I have up here. But they have a difference where they do not take into account numbers that seem to never end. For example, root 2. If you put that into your calculator, let's put it in now, it will give us 1.414213562, and it begins to continue, but my calculator stops there. The reason why that these numbers are not counted as rational numbers is because they never seem to end. These numbers can also, rational numbers can also be put into fractions, as I said, like 3/2, 5/2, etc. Now, aside from that, irrational numbers cannot be written as fractions, and these numbers never seem to end, as I said before. So this can go on to even something like pi. If you know what pi is, then you know that this number always continues to increase and increase, never seems to change, and never seems to stop at any point. And so this will be counted as an irrational number. So to go through this exercise, we're going to look at number 1. Number 1 says, here is a set of numbers: -4, -1, 0, 1/2, 0.75, 3, 4, 6, 11, 16, 19, and 25. So the question then tells us to list the numbers from this set that are A, natural numbers. As you can remember, natural numbers are the positive numbers that start from 1 to infinity. So these are all numbers that start from 1 to infinity. So we can start from the 1A, and you can see that these numbers, -4, -1, 0, 1/2, 0.75, they are not natural numbers, because natural numbers are whole numbers. And 1/2, although 1/2, 0.75 are positive, these are not whole numbers. So we're going to take into account 3, 4, 6, 11, 16, 19, and 25. So B now tells us to give the numbers that are even. Now, even numbers are whole numbers that can be divided by 2. This can include both negative and positive numbers. Even numbers can be both negative or positive. So B, we have -4 here, and -4 can be divided by 2 without leaving a remainder. So -4 is an even number. -1 will leave a remainder, so that will not be counted. 0 is an even number because it will not leave a remainder when it's divided by 2, so that will be 0. 1/2 and 0.75 are not whole numbers. 3 is not there. 4, 6 is going to be there, so 4, 6. 16, and 16 is the last number actually. So then we go to C, odd numbers. So odd numbers cannot be divided by 2 without leaving a remainder. So we're going to count -1, 1/2, 0.75 again will not be counted because they are whole numbers. 3 is there, 11 is there, 19 is there, and 25 is there. Let me clean that up. So after that, they then say that we have to list the integers. So integers and numbers, they are both positive and negative, and they are whole numbers. So we're going to count the positive and negative of positive actually whole numbers, and that's going to be -4, -1. 0 is also going to be counted as it's just is not counting either positive or negative. 0 is still an integer. 3 is there, 4 is there, 6 is there, 11 is there, 16 is there, 19 is there, and 25. Now, they tell us to list the negative integers. So, negative integers are numbers that are less than 0. And these numbers are going to be counted as -4 and -1. They then tell us to state the fractions in this equation. So let me move this question so you can all see. So all fractions in this will include both 1/2 and 0.75. Reason why is because there is a numerator and a denominator, and when you put 0.75 into your calculator, or when you decide to change it into a fraction, it's going to give you 3/4, which is still a numerator and a denominator. After that, we go on to square numbers. So square numbers are numbers that have been multiplied by themselves. These are always going to be positive numbers. Take that to note. Square numbers are always positive numbers. So we have -4, -1. These are negatives, so they will not be counted. And also, one thing to note about square numbers actually is that there's going to be one number that is different, and that is 0. 0 is 0 times 0, and that equals 0. So 0 is also a square number, although it's not a positive or negative integer. It is also counted as a square number. So 0 is here. Another one can be 4, because 4 is 2 times 2, and so that will be 4. After that, we have 16, which is 4 times 4, and then 25, which is 5 times 5. So those are all the square numbers. After that, they tell us that we're to state all prime numbers. And remembering, prime numbers are positive numbers, well, they are greater than 1 actually. Let me just say they're greater than 1, and they can only be divided by 1 and itself. So we'll go on to the prime numbers, which are going to be 3, because 3 can only be 1 and 3. When you do the factorization, it's going to be only 1 and 3. After that, 11 is also going to be part of that, because it's just 1 and 11 that are the factors of 11. 19, same thing, and that's it. After that, lastly, we're to look at the neither square nor prime numbers. Let me erase this. Okay, so neither square nor prime numbers. We can look at all numbers that are not square numbers and they are also not prime numbers. An easy way to do this is simply to just look. We have already found G and H. We already found the square numbers and the prime numbers. So we'll then take these numbers that we have put here, and we're going to remove all those numbers from the total set of numbers that we have up here. So 0 is here. We're going to cancel out 0. Mistake. So 0 is here. We're going to cancel out 0. 4 is here. We're going to cancel out 4. 16 is here. We're going to cancel out 16. And 25 is here. For the square numbers, we have cancelled out all square numbers. As well as that, we're going to cancel out all prime numbers. So 3, 11, and 19 are cancelled out. So the remaining numbers are now the numbers that are not square or prime numbers. So these numbers are then -4, -1, 1/2, 0.75, and 6. So when you write that down, it's not going to be, your answers are going to be -4, -1, 1/2, 0.75, and 6. So if that, we have completed this first question. So we'll then go on to the next. So the next question then asks us to list a set of numbers. So the first question is to list the next 4 odd numbers after 107. So the way we can do this is by simply adding 2 to each number, adding 2 to 107, then adding 2 again to that next number over and over and over again. So for 2a, that'll then be 107 plus 2, that'll then be 109, then plus 2 again, 111, then plus 2 again, 113, and then until we have our 5 consecutive numbers, then that will then be 115. And so 115 is the last, so we're going to then take 109, 111, 113, and 115. So those are the next 4 odd numbers after 107. So next goes to B, which is to list the next 4 consecutive even numbers between 2008 and 2030. So we can do the same thing that we did for the odd numbers, and that's to be adding 2 to the 2008. The reason why we're adding 2 is because the first number, which is 2008, is an even number because it ends with 8. So due to that, we can then just add 2 again to get the next even number. If they are asking us to look for odd, then we'll just do 2008 plus 1. That will then give us the next odd number, which is 2009. Then we'll add 2 again to that to get the next odd number. But here we're looking for the even numbers. So we erase this, and then we'll do 2008 plus 2. That will then give us 2010 plus 2 again, 2012 plus 2 again, 2014, and then let's make sure 2014 plus 2, that will then be 2016. So we have our next 4 consecutive numbers after between 2008 and 2030. And just because we started with 2008 doesn't mean you can't start with other even numbers. You can start with something like 2020, 2024, 2022. As long as it does not go past the range of 2030, then you will be good. So the answers for this example are going to be 2010, 2012, 2014, and 2016. So I'll then erase this. The next question is then asking us to find all odd numbers between 993 and 1007. Because 993 is an odd number because it doesn't have an even number at the end, we can then just add 2 to 993 to find the next odd number. So 993 plus 2, 990, that will be 995, plus 2 again, that will be 997, plus 2, 999. Then for space, let me come here. 999 plus 2, that will be 1001, plus 2 again, 1003, then plus 2, that will be 1005. Reason why we stop at 1005 is because if we add 2 again, that will give us 1007, and we're not counting 1007 because 1007 is the boundary for this question. So our answers are going to be 995, 997, 999, 1001, 1003, and 1005. So that's it for this question. Let me erase this. Next question then tells us to state the first 5 square numbers. So as you keep moving through the whole scheme, you notice that the first 5 square numbers must always start from 1. it doesn't start from 0, because a lot of times they normally don't always start with 0, so they always start with 1 most of the time. So you're going to first start with 1. So we'll have 1, the first one in 0, 1, 2, 3, 4. We'll do 1 square, which is 1 times 1. That will equal 1. So 1 is the first one. 2 times 2, that will then equal 4. That's then the second one. 3 times 3, that will equal 9. That's the third one. And then 4 times 4, which equals 16. That's the fourth one. Then we do 5. So 5 times 5, that will then equal 25. Those are then our first 5 square numbers. But it depends. If the question specifically comes and says that you must start from 0, then you can then do 0, 1, 4, 9, 16, because to be the first 5 square numbers. So then next question then asks us to list the 4 decimal fractions that are smaller than 0.5. So decimals can be, as we have, 0.5, and 0.5 is the same thing as 5 over 10. So you can then just start listing, minusing the numerator by 1. That will then be 4 over 10, 3 over 10, 2 over 10, 1 over 10. And then if you want to make it, due to this only giving us 4 over 10, 3 over 10, 2 over 10, 1 over 10, and we're looking for the decimal fractions, you can just do a smaller, you can just minus 1 by something smaller. So let's see, like 0.5. That would then be 0.5 over 10 or 5 over 100 when you put that into your calculator. So our answers can be 4 over 10, 3 over 10, 2 over 10, 1 over 10, or 5 over 100. Because these are just increasing, they're decreasing rather, they're smaller than 0.5. Or else we can, the reason why this is now not going to be counted is because we're meant to put it in decimals. So 4 over 10 to decimal is going to be 0.4, 3 over 10, 0.3, 2 over 10, 0.2, 1 over 10, 0.1, and 5 over 100, 0.05. How you can do this is by saying 4 over 10. You use this 0 here and then take it like this. You will take the 4 over and put a point here. So this will then be 0.4. 5 over 100. Due to the numbers of zeros, it will then determine the decimal place for the number. So then let me erase this. So you then do 1 and 2. Then this is the decimal place here, and you put a 0. That will then be 0.05. And that will then be your answer for this. So the answer is going to be 0.4, 0.3, 0.2, 0.1, I don't know why there's a 4 there, and then 0.05. So that being said, we then go on to the last question, and that then asks us to find the first 4, well, the 4 common fractions that are greater than 1 over 2 but smaller than 3 over 4. So as we keep going through the curriculum, we'll learn of something called LCM. So we can then do what is called LCM in this question to find the 4 common fractions that are greater than 1 over 2 but smaller than 3 over 4. So let me move this here. So F, 1 over 2 is the same thing as, we can do 1 over 2 and 3 over 4, put them together, and then we can do the LCM of these two. So this is going to be 2, 4. The LCM is going to be 4. And then 4 divided by 2 will be 2. And 2 times 1 is 2. 4 divided by 4 is 1. 1 times 3 is 1. So due to this, we must find the common fractions that is in between 2 and 1 over 4. So I was going to put 3 over 4 here actually. We must find the common fractions that's in between 2 and 3 over 4. We can then simply do like 2.1 over 4, 2.4 over 4 rather. 2.5 over 4, 2.8 over 4, and then like 2.9 over 4. That's still good. These are then the common fractions that are in between, that's greater than 1 over 2 rather, but smaller than 3 over 4. This is the same thing as saying that the fraction has to be greater. So let's give the fraction like x. X has to be greater than 1 over 2, but less than 3 over 4. So that's how it's going to be. So we then continue on, and then these are going to be our answers. And then for us to make it look like actual common fractions, we'll take the decimal place of this over here, and then we'll times this by the decimal place that is taken. So this is taking on 10, 10, 10, and 10 again. So these answers are going to be 24 over 40, 25 over 40, 28 over 40, and 29 over 40. The reason why is because the number of decimal places we're taking is the amount of times that 10 will be times by the denominator. So that's how it's going to be. So our answers, as I've said, are 24 over 40, 25 over 40, 28 over 40, and 29 over 40. With that being said, we have answered this question. So the question now tells us to state whether the following will be odd or even. So now I want you to take this as a note. When there are two odd numbers, when they're asking us to either sum or subtract, sum of two odds will always produce an even number. Same thing as the subtracting. Let me erase this because it may not be easy to see. Subtraction of two odds will also give us an even. So for example, let's say we have 3 plus 3. This will give us an even number. 5 plus 3, even number. 5 plus 9 is a 14. So that will give us an even number. So, and the same thing goes for when you subtract. So 9 minus 5, that is 4. This is even. 9 minus 7, that is 2. That's also an even. So whenever you sum or subtract two odd numbers, they always give you an even number. So the answer to the first one, which is the sum of two odd numbers, will be given as even. Question B has them asking us the sum of two even numbers. The same thing for the odd numbers will also be the same as even numbers. The sum of two evens well, even numbers, but always give us an even number, and the subtraction will always give us an even as well. An example can be given as, like, let's say 2 plus 2, that's 4. 2 plus 6, that is 8, and etc. As long as you keep going, they'll always give us an even number. The more you do these calculations, the more you see that every number that is both even, when you are asked to subtract or add two even or odd numbers, they'll always give you an even. So that's your answer, is going to be even. Question C has them asking us to state whether the following will be odd or even. Will state that the sum of an odd and even number will either be odd or even. So an odd and even number, something to note now, let me erase this, is that, as the question says, that what's the sum of an odd and even number. When you add, funny enough, this should be addition of odd and even. Will always give an odd, same as the subtraction. an example is 9 minus 4 equals 5. 20 minus 11 will equal 9. These are both odds. So whenever you calculate, whenever you add an odd or an even, that will give you an odd number, and whenever you subtract, it will also give you an odd. So your answer here is going to be odd. Erase this. So question D then asks us to state whether the square of an odd number will be even or odd. So for example, 3 square will equal 9, 5 square will equal 25, 7 square equals 49, 9 square equals 81. The more you go, the more you realize that the squaring of an odd number will always give an odd number. So your answer there is going to be odd. And now for question E, the square of an even number, same thing goes. 2 square equals 4, 4 square equals 16, 6 square equals 36, 8 square equals 64, and the list goes on. It will always give you an even number. So your answer there is going to be even. And the last question is question F. We are to state if an odd number multiplied by an even number will give us an odd or an even number. So an odd number, let's give for example 3, and an even number, for another example 4, will give us 12, and that is an even number. Let's do it again, like 6 and times 5, that is 30. That gives us an even number. 12 times 15, that is 180. That gives us an even number. As you keep going more and more, you find out that the multiplication of an odd and even number will always give an even number. So the answer there is even. And with that, we found all answers for the 3 questions under the numbers. And so that is it for this area.